Okay, so here are the answers to the homework. You can pause, check, and then here are the last three. Okay, so let's go ahead and take a look at our notes. Okay, we're stepping out of chapter 7 and just covering one section in chapter 5 because it ties in with, part of the notes tie in with what we're doing in chapter 7. So we're going to kind of two parts of the notes. We're going to take a look at dividing a polynomial, which is when you're adding more than one term together, dividing it by a monomial, which is just a single term. Okay, so when we want to divide a polynomial by a monomial, basically we're going to take each term from the polynomial and divide it by that monomial. Okay, so kind of what we're going to be doing is setting up separate fractions. So I'm going to take each term from the numerator and divide it by the denominator. Okay. And now then we're essentially going to reduce each fraction. So 15 divided by 5 gives us 3. And then how you do the x's, you can subtract the exponents or just ask yourself kind of where do you have more x's on top. So we'll put the x up on top with the 3. And then how many more? Just subtract 4 minus 1 gives you 3. Then minus 5 divided by 5 is 1. You can put the 1 there or you don't have to because we will have some x's in place there. And then looking at the x's, we have more x's on top. How many more? 3 minus 2 is 1. And then lastly, we have 10 divided by 5, which is 2. And then I have the same amount of x's, so those would just reduce down. And that would be my answer there. I don't need to do anything more with it. Just leave it just like that. Okay, so let's take a look at our second one. We'll kind of do the exact same thing. We'll take each term from the top and divide it by that single term on the bottom. Oh my. Okay, so I'm going to pause the video and write it. Okay, so if you notice right off the bat, it's not going to reduce perfectly like the previous example. So we're just going to reduce negative 10 over negative 4. 2 will go into both. And a negative divided by, oh, it was a positive 10, sorry. So that would reduce to a negative, oops, and I want to change the color. Okay, so it would reduce to a negative 5 over 2. Okay, and then looking at the a's, where do we have more? So look for the larger exponent, and that's on top. So we'll put the a there, and then we just subtract the big number minus the small. So 4 minus 2 is 2. And then they have the same amount of b's, so those would reduce down. And then we'll take a look at the second fraction. Negative 8 divided by negative 4 gives us a positive 2. And looking at the a's, where do we have more? So I can see I have the larger exponent on the bottom. So that's where I'm going to put the a. And how many more? We just subtract the big number from the smaller. So 2 minus 1 is 1. Looking at the b's, where do I have more? Well, my larger exponent is on top. And how many more? I just subtract the big number minus the smaller. So I just have one b on top. 12 divided by negative 4 gives us a negative 3. Where do I have more a's? On top. And how many more? 3 minus 2 gives me 1. And then where do I have more b's? Well, I have one more b on the bottom. And then lastly, it won't divide evenly. So 6 divided by negative 4 reduces to a negative 3 over 2 because 2 will go into both. And looking at the a's, where do I have more? I just have one more on the bottom. And where do I have the b's? Or more b's, just one more b on the bottom. I can't do anything more. I have to leave them as separate fractions. So this would be my answer here. Okay, and then let's just take a look at the last one here together. So same thing. Okay, I'm going to take each term from the top and divide it by the bottom. Now, if you want to be a little lazy like I get sometimes, instead of rewriting the whole thing, I can just put the 7a squared b squared under that second term. And so I'm going to reduce. 28 over 7 reduces to 4. Where do I have more a's? Well, I have one more on top. The b's, I have 3 more b's on top. And then 42 divided by 7 gives me a 6. Where do I have more A's? Well, I have 2 more on top and then 1 more B on top. And that is my answer there. Okay, so why don't you guys go ahead and try the next one on your own. So I'll pause the video while you work it, and then you can check or hit play to check your answer. Okay, so remember we take each term from the top and divide it by that denominator, and then we reduce. So we're left with the 8. I have 1 more x on the bottom, and the y squareds will cancel out. Okay, and then it's minus. I still have the 9 on top. I have the same amount of x's, so those will reduce down, and then I have 1 more y on the bottom. And then lastly, the 6 won't reduce. I have the same amount of x's and y's on top and bottom, so those will reduce down. And again, you leave them as separate terms. Do not put it in like one big fraction bar. Just keep them as separate fractions. Okay, and then let's take a look at the second part, and this will kind of go along more of what we did last class. So if you notice, we're dividing a polynomial by a polynomial. So what makes it a polynomial is that we're either adding or subtracting terms together. So it's not a single term. Notice there's some addition or subtraction going on in the bottom. That is your clue that you're going to have to factor before you can start to reduce. Okay. So in looking at our factoring, on top we have the trinomial here. Since there's a number in front, we're going to use our AC method. So remember, we multiply the first and last together. Okay. So if you want to make your X method, so we're looking for what two numbers multiply to give you negative 18 and add to give us a negative 3. So those factors should be what, a negative 6 and a positive 3. So these two numbers aren't what we plug into our parentheses. They're just going to help us to rewrite our problem. So remember, first term stays the same. We replace that middle term of negative 3x with our two factors. And then my last term stays the same, so I'll bring down the negative 9. Remember, we split our problem in half. Our common factor on the left side is 2x. So then we're left with x minus 3. Don't forget to bring down the sign after the split, so it's a plus. Common factor on the right is 3, and when I factor out a 3, I'm left with x minus 3. So notice it matches inside the parentheses. So that's going to be one of my factors. And we said if we take out those parentheses, what I have left is a 2x plus 3. So that gives me the second set of parentheses. Okay. Now I can't factor the bottom, so I'm just going to carry over the 2x plus 3. Now, as long as you do your factoring correctly, one of those sets of parentheses on top should match with the factor on the bottom. So then that way we can cancel those out or reduce those. So we're left with x minus 3. Okay, and let's take a look at one last one here, and then we'll have you try one on your own. So for this problem here, there's no number in front of the x squared, so you can use your magic question. So we're looking for what multiplies to give us a negative 7 and adds to give us a negative 6. So our two factors should be a negative 7 and a positive 1. Now remember, with the AC method, okay, these two numbers are what we plug inside the parentheses. Okay, so we know it'll break into two sets of parentheses. I have my x minus 7 and an x plus 1. Okay, now notice I have this little y squared here. Okay, we're going to break it apart the same way we did the x squared. So the y squared will break apart into a y and a y. So it factors into x minus 7y and x plus y. Now I can't factor the bottom, so I'll just carry it over. And again, as long as you do your factoring correctly, one of your sets of parentheses should match with that bottom factor, and it does. So I can reduce down the x plus y's. My final answer is x minus 7y. Okay, so there's one problem that I'd like for you to go ahead and try on your own. Okay, notice you have a number in front of that x squared, so you have to think about which method you should use. So go ahead and pause the video and go ahead and work through. And once most folks are done, go ahead and hit play to check your answers. Okay, So since there was that number in front, we had to use our AC method. So we multiplied first and last together to give us a negative 20. Okay, so if you're doing your X method, the negative 20 goes on top. We're looking for what multiplies to negative 20 and adds to a positive 1. It'd be the factors of negative 4 and 5. Remember, those don't give us the numbers in our parentheses. They just help us to rewrite our problem. So first term stays the same. That's a 2x squared. We replace the middle term with our two factors. I put the negative 1 first, so it's going to be 2x squared minus 4x plus 5x, and bring down that last term of the minus 10. We split it in half. Common factor on the left side is 2x, so then we're left with x minus 2 in the parentheses. Make sure you bring down the sign after the split, so it's a plus sign. Common factor on the right is a 5. If I divide both by 5, I'm left with x minus 2. So it matches in the parentheses, so that's one of my factors. What I have left, okay, if I take out those parentheses, I'm left with 2x plus 5. So it factors into x minus 2, 2x plus 5. I carry over the denominator since I can't factor it. And again, we said it should match with one of the sets of parentheses on top. Since it does, we can go ahead and reduce those down. So we're left with the answer of 2x plus 5. Okay, so we're going to give you a chance to kind of practice a little bit with your notes with some problems.